This video is a second type problem for nuclear energy calculations. We're going to deal with carbon dating problem. Now let's read the problem. A tiny piece of paper taken from the Dead Sea Scrolls, believed to date back to the 1st century AD, was found to have an activity per gram of carbon of 12.1 atoms per minute. So it was scanned, okay, as the activity at 12.1 atoms per minute. So taking AO, or the initial activity for carbon, as 15.3 atoms per minute, estimate the age of the scrolls. Now let's proceed. Now we are given with an activity AT is equal to 12.1 atoms per minute, and our AO is at 15.3 atoms per minute. Now we are going to determine the age of the scroll in terms of time t. Now let's proceed with the solution. First is we need to solve the decay constant via half-life of carbon-14. Now, K now is equal to the natural logarithm of 2 all over the half-life of carbon, C14. So let's substitute the natural logarithm of 2 all over 5,730 years. This gives us an answer of the decay constant for this problem at 1.2097 times 10 raised to negative 4 per year. Now let's proceed in determination of the time. Okay, so we have this formula for the activity as natural logarithm of any activity at any time t at all over the original activity for carbon is equal to negative decay constant k times t. So manipulating the whole equation, dividing both sides of equation with negative decay constant, this gives us this form as time is equal to the natural logarithm of AT all over AO all over negative decay constant k. Now let's substitute the following values. This gives us time is equal to the natural logarithm of 12.1 atoms per minute all over 15.3 atoms per minute all over our decay constant at 1.2097 times 10 raised to negative 4 per years. Okay, so this is negative. So our time now is equal to 1,939.72 years ago. Okay, so almost nearly 100 years ago since Christ's ascension to heaven. Now, that ends my presentation for carbon dating problem. Our next video is a third type of sample problem for nuclear energy calculations.